It is May 12th, Monday. Driving to work this morning, want to do a truck brain dump. In this brain dump, talk about the workflow that we go through to process and adjust our raw survey measurements from the field in Trimble Business Center. That's a software that we use here at Redefine Horizons for that purpose. Other companies might use software like a Geomatics Office or Topcon Tools. It's a very important part of what we do. So let me tell you why briefly. Why is this important? Our ability to process and adjust our raw and analyze our raw survey measurements. It's important because we're supposed to be expert measurement makers. So we are. And so we don't want to let the software on our data collectors, our instruments do all that math and not have some supervision of the process or insight into the quality of the measurements. So that's the first reason we are supposed to be expert measurement makers. And part of being an expert measurement maker is understanding what's happening with your raw measurement data. So we don't want to just take points out of an instrument or a data collector like it's a black box. We want to understand what's going on, and we want to do some peer review, so to speak. So we're expert measurement makers, number one. Number two, it actually improves the quality of our data. So when we run a best fit adjustment, when we do some processing and run a best fit adjustment, if we follow good procedures in the field, we'll actually remove some random error and remove blunders, and we'll be able to detect and remove blunders and outliers so the quality of our data will improve. Number two, and then number three, we'll be able to assess the precision of our data and potentially the accuracy of our data. And we can quantify that even with some statistical measurements. Now you notice I didn't put having better measurements as number one. A lot of people think that's the most important reason why surveyors do processing and analysis and adjustment of their raw measurement data. And I don't think that's true. I think that's a misunderstanding of how surveyors add value. Super tight network adjustments and super precise measurements they're not a bad thing necessarily, but they're not always what the client needs, and they're not always what the client should pay for. Sometimes the effort to achieve that level of precision is a waste of money. I think the more important reason is because we're experts and we need to understand our own measurements. So that's the most important reason. It's about having good habits as a land surveyor. It's like brushing your teeth and eating your broccoli. You can skip a few days of not brushing your teeth or not eating vegetables, but eventually in the long run, those are bad habits. It will catch up to you. So we want to build good habits. When we tell people we're land surveyors, we want to back that up by being experts in our measurement making. And then a really important part of what land surveyors do is analyze and communicate with confidence about the precision and accuracy of their measurements and of their geospatial data. And that's something that sets us aside from other professionals like GIS professionals or construction layout folks. That's the difference between a land surveyor and a carpenter. A carpenter might be able to tell you how far it is from point A to point B on a job site, but a land surveyor can tell you how far it is, and he or she can give you the level of confidence they have in that measurement. That's why it's important. I'll wrap up that section with just a little side note. Almost all of the companies I have worked at, land surveying companies I've worked at since college, do not do a good job of this. So a lot of those companies just take points right off of the instrument. They don't do any review of the raw measurement data, no adjustment, no processing, no analysis. It's a horrible habit. Surveyors that practice in that way should have their license revoked, in my opinion. I only worked at one other company that did a good job of this, that did a good job of what we're going to talk about today conceptually. So it's important. And it's important for my team members at our age to learn how to do this. Okay, so I mentioned the tool that we use to do that is Trimble Business Center. So I just want to talk briefly about how we organize our Trimble Business Center project files and the type of data that goes into them. So I'll do that in this next section. So we have three basic types of Trimble Business Center projects. So in the first, there's two categories. There's what we call network projects, and then there's working projects. So in our network project, that's where we put the data that essentially becomes our published in air quotes or our record in air quotes coordinate values, adjusted coordinate values. So in what we call our primary network project, we have our primary control. So that's usually one or more GNSS base station points that we've tied out to NGS cores or maybe PBO stations, but we're ultimately tying to either to NGS cores or to PBO stations, and that allow us to get on the NAT 83 North American datum of 1983. And we're doing that either per NGS cores or maybe, depending on the project, we might be using the California Spatial Reference Center, CSRC values, if we're working here in California. The secondary network project we'll have our primary control values after they're published, set to control quality. And then we use the secondary network project to process data, could be secondary control points, and it could also be property corner monuments. So that would go in the secondary network project. So the main difference between the primary network project and secondary network project is the primary network project, that data is all going to be static data, almost always static data. So no PPK or RTK. And it's almost always tying primary control points to cores. In our secondary network project, we could have a mix of static PPK and RTK, depending on type of survey we're doing. But there's still going to be a network adjustment. So both the primary project and the secondary project have some kind of network adjustment. Oftentimes, the secondary network project will not have ties to cores or PBO stations. So we've already established primary control on site, and then we're just tying to those primary control points with shorter baselines. That's a pretty typical pattern for us. As a general rule, especially on a small to medium-sized project, the secondary network project is going to be a little more dynamic and regularly updated than the primary network project. So on a small project, we'll go in, we might set 2 or 3 GNSS base points and process those to cores, connect those to core stations in the primary network project, and then those coordinate values get locked down and they don't move again. We don't necessarily get back into that project to add data or to change those coordinate values. Then we have our working project. So our working project is where we check in our daily jobs. So that's after we've established primary and secondary control, and now we're going in and we're doing PPK surveys, RTK surveys, or total station surveys. That project does not typically have a network adjustment. It might have a traverse adjustment, although my preference would be those traverse loops get put back into the secondary network project. So we don't typically have a network adjustment in the working project. That's where we're checking in our daily jobs. We basically already have good control values, good control coordinates, and we're just processing our actual survey measurements for topo or aerial targets are getting processed to that primary and secondary control. We don't do a lot of topographic surveying with GPS or total station, but if we were out, for example, on a site, maybe mapping utilities with the total station, that data would be processed in the working project. The working projects are a lot more dynamic, so they're updated every day. Almost every day that we're out in the field, those projects are being updated. That's a description of how we organize our data. Not all projects will have all three kinds of projects. You might have for just a control survey, you might only have a primary network project. If you're just doing primary control and then you're just tying out utility marks or surface utilities on a small site, you might just have a primary project and a working project. If you're going to do a boundary survey, so you set your primary control and then you're just doing some PPK observations to a half a dozen proper corner monuments on a rural parcel, you might only have a primary network project and a secondary network project. You might not have a working project in that case. So it's going to vary project to project. You will almost always have a primary network project, though. Here at Redefine Horizons, we try and have on state plane coordinates. So we're geospatial, not just spatial. And we do that with primary project. Okay, so now that we've talked a little bit about what goes in each of the three types of Trimble Business Center projects, let's talk at a high level about what we're conceptually doing in those projects. And I talked about it briefly, but I'm going to get into just a little more detail. This isn't going to be a how-to. I'm not going to teach you how to do it. We have some other great training material about that, but I want you to understand at a conceptual level what we're doing and why we're doing it. Okay, so in a primary network project, what we're doing is we're taking static GNSS observations on two or more receivers, and we're processing that in the baseline. We're using the baseline processor to take that raw satellite measurement data that's logged by the receivers. And we're essentially converting that into 3D vectors. So it's a 3D line. Okay, we call it a vector or baseline. So we're taking that raw GPS data and we're creating a set of 3D vectors. Okay, so it forms hopefully closed loops of 3D vectors, right? Which allows us to check loop closures. And it's a QA, QC step. How well do our measurements fit together with one another, right? Do they form closed figures? And there's always a little bit of error in there. You can see that in the loop closure reports. And I want you to understand, after you've imported your data and done the initial baseline processing, we have good survey grade 3D vectors, survey datum yet. So that raw GPS data is going to be on WGS84. That's the coordinate system that we use to drop bombs. Right? That's what the United States uses to drop bombs. So WGS84 is the GPS that navigates you around in your car. It's great for dropping bombs and for cruise missiles. It's not so good for surveying, especially in North America. So we want to get it on the North American datum of 1983. That's the current horizontal datum that we're using in the United States. So to do that, we tie to NGS cores. Typically, we might be using CSERC values, or we might be using the latitude, longitude, or state plane coordinate values from the NGS datasheet. Okay, what that does is that moves us from the WGS84 horizontal datum to the NAD83 horizontal datum. Okay, in our part of California, it's about a 3 to 5 foot shift, mostly in the easting. And now we're on a good survey datum. Okay, and because we tell TBC that we're in state plane coordinates, it's going to project those NAD83 latitude, longitude values to state plane, and we're going to have good NAD83 state plane coordinate values, which is what we survey with here, and RH most of the time. So now our data will overlay with other types of GIS data, right? So it's the best of both worlds. We have good survey accurate data, but it's on a known state plane coordinate system, so we can integrate it with other kinds of spatial data. So that's what we're doing in a primary network project. We are processing that raw GPS data to get good survey grade 3D vectors. We're checking some closures. And then we're running a network adjustment with some ties to some core stations. That network adjustment's getting rid of our random error and getting us some best fit values. So comparing all the measurements together in a bundle and coming up with the values that fit best, all the measurements, all the individual measurements, right? It gives us some statistics. so we can understand how confident we are in the precision of our measurements. And then what we're typically doing when we're done with that process is we're exporting a point file with our northing, easting elevation values for our primary control points on state plane. Okay, we also will export our combined scale factor out of our network project. Usually, we'll save a loop closure report and we'll save a network adjustment report also. We follow a fairly similar process in the secondary network project. So we're importing static data or PPK data or RTK data, and we're processing that GNSS data, the raw GNSS measurements, so that we get good survey grade 3D vectors, right? We might be checking some closures. Okay, the main difference, as I mentioned before, is we're not typically tying to cores there. We already have some local control points, some primary control points that we're using as our GNSS base stations on the job. And we're pushing those good NAD 83 state plane coordinates from our primary control out to our secondary control points or our property corner monuments. Be doing either one of those in the secondary network adjustment. And then we're exporting point files for our secondary control and our property corner monuments out of that project. They're state plane coordinates, just like in the primary network project. But we follow the same basic workflow in both types of projects. You import your raw GNSS files from your receivers. Usually they're Rhinex files. You're processing the baselines. Maybe you're importing an ephemeris. You're processing the baselines. You're checking loop closures. You're doing a network adjustment. The workflow in the working project is a little bit different. So in that project, we've already imported our primary and secondary control points, their control quality, so they're not moving around. We're typically checking in a daily job file. If we're doing work with a total station, that's coming in as a daily job file. If we're using our GNSS receivers, we're importing more Rhinex files. Those vectors are coming in. We're checking those vectors. We're looking for flags. If they're PPK vectors, we're processing those. We're checking for flags. We're double checking rod heights and instrument heights. We're overlaying those points and vectors on Google Earth to make sure they look like they're in the right place, roughly in the right place. We're visually checking our measurements and saying, did the field crew do what they were told to do? Did they set control where they were told to set it? Did they do it with the method that we told them to use? Did they collect the data we told them to collect? Is their topo 30 feet from the edge of the pavement like we told them? Whatever. We're doing some QA/QC there. So it's not just about the measurement data itself. It's about our scope of work and did the field crew do what they were supposed to? We're doing things like managing our point data, making sure that we don't have overlapping point numbers, making sure that our data was collected with the right point range and has the right feature coding and descriptions. So all that happens in the working project. As we talked about before, we're not typically checking loop closures in the working project, and we're not running a network adjustment usually in the working project. One thing I forgot to mention about the secondary, typically this would happen in a secondary network project, is we might also be importing total station data for control. So it could be a closed loop traverse. We don't always traverse, but it could be a closed loop traverse. It could just be good direct reverse total station observations that are adding redundancy to our network. Not necessarily, total station data might not necessarily be in a closed loop. That's one of the advantages of using a best fit adjustment. So we might import that total station data and combine that into our network adjustment in the secondary network project. Now, sometimes what that means is you don't always get to cleanly separate your total station control observations from your other kind of working total station observations, your topo, for example. So in that case, you might import a daily job into your secondary network project that has some total station control observations, and then you might delete the other, what we call side shots, so that you only have the control ties from the total station file, because you don't want to contaminate or clutter your secondary network project with a bunch of topo side shots. I always try and mix total station measurements and GNSS measurements in the secondary network project when I can. It's a great way to add some redundancy and to do some error checking. So it's always a good idea to try and mix those measurement types to do that. So that at a high level is what we're doing in Trimble Business at RH. It's a lot of work, but we're good at it, and it's good habits. Remember, it's like brushing your teeth or eating your broccoli. Not just take point files off an instrument here. That would be a betrayal of everything we stand for as expert measurement makers. So that's why we do what we do in Trimble Business Center. Again, today was more about teaching you what we do and why we do it in Trimble Business Center, not teaching you how we do it. So I hope this helps my folks, Matthew and Austin and Elena and Bob and Tristan and Britt and my other survey technicians understand kind of why we do what we do in Trimble Business Center and how that all fits together. This took way longer than I thought. I'm at almost 25 minutes. Obviously, that's not simple, right? If it was simple, this would have been a shorter recording and everybody would be an expert at it. It takes a long time. It takes lots of practice to get good at Trimble Business Center, but it's a vital skill. It's a vital skill if you want to be a land surveyor and an expert measurement.